What we have learned so far, blocking, that is one way of tackling confounding. So the main problem with confounding was that you were changing two arrows, two inputs to your black box simultaneously. And blocking was one way by which you can prevent this when one of your arrows or one or more of your arrows are what are called control factors like gender or smoking habit or age group, things that you are not administering yourself. Now, a very similar concept works even for the random error input, because that is also an input. Unfortunately, here you cannot just say that I will hold the random error fixed at a certain value while I will change the other input. Whenever you change any input and you take fresh measurement, the random error input will change. It is not under your control. So the idea of blocking does not directly apply to that random error input, but something less satisfactory may be done. And that is the idea behind randomization. The idea is, since the random error input will keep on changing, you can at least hold the other inputs fixed and allow only the random error input to change values. Now this takes two forms. The first form is called a repeated measures experiment. So it is like this. Suppose we are trying to understand the behavior of a spring. Our familiar example, we hang some weight from the spring and we measure the length. Then in the next experiment, we just carry out the experiment again from the beginning. We remove the weight, let the spring return to its original length, and then again we hang the same weight back on the spring. So the only thing that changes from the last case is the random error. So let only the random error change, hold everything else fixed. This is called a repeated measures experiment because you are repeating measurement with all the setups held fixed, and it is a very frequently used technique. We all know this when we carry out experiments in, say, a physics lab. Whenever we want to measure a length, we typically measure it multiple times. That is also an example of a repeated measures experiment. You are allowing only the random error to change. Of course, this is only half of the story. The other half should be, now you keep the random error part fixed and you change only your input. Unfortunately, you cannot do that. If you are able to do that, then you do not need any statistics at all. If you can keep the random error under control, then of course you do not need statistics. So you can't do that. So it is just sort of the one half of the idea of blocking. Now the same concept may be used in a slightly different way, and we have already used them in this way. It is when we are doing random allocation. Say you have got some 20 plots and you have got 4 varieties. So you have decided to allocate 5 plots to each variety. Then this allocation must be done randomly, because even if you believe that all your plots are as identical as possible, still you have to, so there will be some amount of variation, and you want to give everyone a fair chance for those variations. So you want to do a random allocation. So randomization takes two forms. One is repeated measures experiment, where the factor that we are working with is something that is either a treatment or something that we can hold fixed, and we have this random allocation idea where within a fixed number of objects you are allocating your treatment in a random way.